Hey there kids, welcome to another math video. One of the last ones for Module 2, getting near the end. Yay! I love finishing Module 2. It's such a bear. This is grade 5, lesson 28 homework, and it's word problems. If you look at the objective on the bottom, it says solve division word problems involving multi-digit division with group size unknown and the number of groups unknown, and basically everything is unknown. You just have to read them, think about it, draw something if you can, and solve it. So we really have to think about logic here. All right, let's get started. Number 1, Mr. Race needs to replace the 166 and 2500th foot of edging or feet of edging on the flower beds in his backyard. The edging is sold in lengths of 19 feet each. How many lengths of edging will Mr. Rice need to purchase? So anytime you can, it's always good to say, make a tape diagram. Look for any totals that they might give you. So if he needs to replace this edging, then we just call the edging the total length. I always try to put the total on the top. The edging is sold in lengths of 19 feet each. How many of these? ... to the question mark. If this is 1 and this is 2, we don't know up to here. We know that they're all 19. That is a division problem. So you look at your total and you say, I got to split it up in groups of 19. So set that up with your decimal and decimal up as soon as you can. And think, I wish I had 20. If it helps you to write out the expression like this, so that you can then have your rounded number, and then you can kind of think about parts like that. Like, you got all this space, make use of it. Okay, so if I have roughly 20 and it would not fit into 16, then it would have to be into the 166. So counting by 2, I would say, well, that's going to be at least 2 times 8 is about as close as I could get. I could do 2 times 8 is 16, and that's going to be really close to the 19. So I can try the 8 here in this ones place. Notice I didn't say ones over here because I've got my place value determined because of the decimal. So start multiplying. 8 times 9, 72. 8 times 1 plus 7, 15. Pretty close. So do your subtraction. End up with 14, and then we're going to do our bring down because your quick comparison shows that 14 is less than 19, so we can move on. Now remember, it's all about place value. So if I have 142 tenths, that is now what's being divided by my 20. Use that rounded number. And so again, if I multiply 2 times 7, we were doing a review in class, and I said, when you divide first, the number has to go in your quotient first before you multiply. I have a lot of students multiplying first, and then what happens is they forget to put the digit up there, and then sometimes they have the next digit in the wrong place. So it has to be divide first, then multiply. 7 times 9, 63, using a 6 here. And then 7 times 1 is 7 plus 6 is 13. Subtract, and if you think about 33 to 43, that's 10, so it's 1 less, so you would have 9. You can use the standard algorithm if that makes you happy. 9 is less than 19, so bring down. 95 is now what we have to divide with our almost 20. And so 20, 40, 60, 80, and finally it's not 20, so I can use 5, because if you look at this, 5 times 9 is 45, using the 4, and 5 times 1 is 5 plus 4 is 9. Hello, Bob. So 8.75 what? Let's go back to what we're dividing. This is feet here. Then the edging is sold in feet. So how many lengths? So it's 8.75 lengths. So what does that mean? A lot of what you're doing today is thinking about your remainder or the non-whole number. So it's going to be like a decimal fraction. And what do I do with this? So if you go to Home Depot and you say, oh, I need 8.75 lengths of edging, they're going to say, okay, well, no, they're sold in lengths of 19 feet each. So you get whole lengths. So that would be a bump up to the next hole, WHOLE, the whole thing. So it's 8 lengths, but I'm going to have to get 9 by 9 lengths. Otherwise, they'll laugh at you at Home Depot and say, get out of here, we're not cutting it for you. Okay, so by 9 lengths, that's all. You have to cut it yourself, and then you have a little bit of scrap. A lot of projects end up with a lot of scrap. So anyway, just a fact of life. Okay, next problem. All right, Olivia is making granola bars. Hello, Olivia. She will use 17.9 ounces of pistachios, yum, 12.6 ounces of almonds, yum, 12.5 ounces of walnuts, yum, and 12.5 ounces of cashews, ooh, my favorite. That looks like a lot of great nuts. This amount altogether makes 25 bars. How many ounces of nuts are in each granola bar? So good thing they have labeled everything in ounces, ounces, ounces. That means we can combine all those ounces together and then divide. So this is a 2-step problem, unlike the first one that was really just one. Take each amount and line up your decimals very carefully. Place value matters. 17.9, 12.6, 12.5, 12.5. Now students will do a huge variety of adding. They'll do 2 at a time, add 1 more. You can totally do that. I tend to just throw everything in one big pile and add them all up. Okay. I also like to try to make 10s whenever I can because it's helpful. So if I see the 5 and 5 making a 10 and then a 9, I'll say 19. 19 plus 6, 25. Carry that and decimal down. I love counting by 2s. 2, 4, 6, 8. 8 and 7, 15. You can also do 7 plus 2 is 9 and then count the odds if you want. 1, 2, 3, 4, 5. That gives us some fun 5s. And so this amount makes 25 bars. So we have 25 bars. How many ounces of nuts are in each granola bar? We're going to take our 55.5 decimal up. It totally matters. You don't want to leave it incorrect. And you want to divide by your 25. So starts out easy enough. 2 25s, that'd be like 2 quarters, makes 50. Leaving you with 5, which, yay, move on, gives us another 55, so we know that's 2 again. Bring down the 5. Now if I have 0, so I'm going to annex like we did in the previous lesson. If you can annex a 0, it might actually help you wrap up your problem. So you drop down that 0. Now you know you have 50, which is exactly the 2. 2 times 25 is 50. Subtract and get 0. Hello, Bob. Okay, and so how many ounces of nuts are in each granola bar? This is exactly how many ounces of nuts in each bar. There you go. Okay, so hopefully that's helping you out. These problems are pretty hard. I know I was never a word problem person when I was a kid, so kind of like the tape diagrams though. Not gonna lie. Okay, Adam has 16 and 45 kilograms of flour, and he uses 6.4 or 6 4/10 kilograms to make hot cross buns. The remaining flour is exactly enough to make 15 batches of scones. How much flour in kilograms, thank goodness they're not changing the units, will be in each batch of scones? So, all right, make a tape diagram just to see what's happening. What's the total? 16.45 He uses some to make hot cross buns, so we have to show that that is used on the hot cross buns. Okay, so that's actually gone. What happens when it's gone? The remaining flour, which we have to try to figure out how much that is, gee, I wonder what you should do, is enough to make 15 batches of scones. So if you split it in 3, then you put 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then those are the batches. And the question is how much flour in kilograms will be in one batch, which is also a fancy way of saying each batch. And that's going to be scones. See, there's your 15 batches. So this is a picture of what we're going to do. First step, you should see that you'd have to take your 16.45 and remove 6.4 because that has, it's no longer going to be part of those scones. Okay, so you have to take it away. Another thing, caution, you have to line up your work. This is even crazy. It's like, it's not even lined up very well. Okay, so line up your decimals because each place value position can only pull from that same place value position. Put a 0 in here and do your subtraction. 5 minus 0, 4 minus 4, decimal down, 6 minus 6, and 1 comes down. This is the amount of kilograms of flour that's left to divide with all of the batches of scones. So how many batches of scones? Well, we have 15. So take your 15 and set it up and put your decimal in and divide now. Now 10 is not divisible by 15, so put a 0 in the ones place. You don't have to put 2, just put the 1 right there in the ones place. And then divide 100 by 15. If you divide 100 by 15, you can skip count by 15s. 2 15s are 30, so then you go 30, 60, 90. So that can be a 6. Notice how I show with my fingers when I'm skip counting. Okay, you can do that too. 6 times 5 is 30, and then 6 times 1 is 6 plus the 3. There's your 9, 90. The difference between 90 and 100 is 10. I'm not going to bother regrouping because I know the difference. And then I'm going to bring down my 5, and now I have, look, if I had 6 for 90 and I add 5 more, I can do 7 here. 7 times 5, 35. Use the 3. 7 times 1 is 7 plus 3 is 10. So that gives us the exact kilograms, because this is all the kilograms for the scones, and this is 67 hundredths kilograms of flour in each batch of scones. Now again, I hope you guys already did this work on your own and you're just double checking. It's really good if you give yourself the opportunity to think about these and do what you can. Even if you only get halfway through, it's really better if you kind of struggle through it a little bit. All right, there are 90 fifth graders going on a field trip. Yay, each student gives the teacher $9.25 each one to cover admission to the theater and for lunch. So that's for both items. Admission for all of the students, that's for the one, will cost $315, and each student will get an equal amount to spend on lunch. How much will each of the fifth graders get to spend on lunch? So we have to do a couple things here because we have to put the money together and then we have to take it apart in a different way. So 90 kids pay this. So let's do a multiplication problem. That's essentially like repeated addition 90 times, but we don't want to do that. We want to do multiplying. So set that up. It's easy when you have a 0 on the bottom. 0 times everything is 0. Move over. 9 times 5, 45. Then we have times 2, 18. Plus 4 is 22. This is 81 plus 2, 83. This is a money question. It's hundredths times ones. Money. So it's hundredths. $832.50 is collected. So if all this money is collected and then we have to spend the money for the admission, we need to remove that. Okay, so take your 8, 32, and 50 cents and remove the $315. Be careful though. It's 315 whole dollars and no cents. Where does it go? It goes here. Okay, so line it up properly. This is ones, this is ones. Those have to be lined up. Just put a couple of zeros here if you don't like the blank. Now take this away from the top. 0 minus 0, 5 minus 0, decimal down. 2 minus 5, you can't flip it around. Go next door, take 1, give 10. 12 minus 5, 2 minus 1, 8 minus 3. Money. This is what's left after paying admission. Okay, and so that's what's going to be split. Now we can divide this by the 90 kids so we can figure out how much each kid gets for lunch. So take that 5.17 and 50 cents and divide it by 90. Ooh, and another thing you can do is you could divide it by 9 and then divide the whole thing by 10. So I can do that too. I already set it up with 90, so I'll just proceed. Decimal up. I'll write that over here. 5.17, 50. Divide by 9, then divide by 10. Remember that strategy? Totally works. Okay, so if we're dividing by 90, we're going to have to start with the ones place because 51 is not divisible by 90, so we need the 5.17. So how many times, again, 9 could fit into 51, 45. 9 times 5 is 45, but 9 times 6 is going to push us over the 51. So multiply 5 times 0, 5 times 9. Subtract. The difference between 45 and 51 is 6. I have a big remainder, but it's still plenty to work with for less than 90, so I'm going to proceed. Bring down my 5. Okay, 67 and 5/10 or 675 tenths divided by 90. And again, think about the multiples of 9. Get as close to 67 as you can without going over. If I have 7, I'm going to have 63, so let's use that. Subtract, subtract. Nice remainder, less than 90, bring down. Thinking about what we already got up here, 450. If you already did the work, try to notice those things. 90 times 5 is 450. Subtract. Hello, Bob. So this is the amount for each 5th grader to spend on lunch. For each child for lunch. Okay, so there you go. And there is one more. And click subscribe and come back again if you are finding these videos helpful. Okay, and you might not need them every day, but it is nice to be able to see what I'm posting. All right, here we go. Last one. Ben is making math manipulatives. What a great kid. To sell. He wants to make at least $450. Each manipulative costs $18 to make, and then he's selling them for $30 each. So he's going to try to make profit after you pay your expenses. Then you want to have some money left over. What is the minimum number he can sell to reach his goal? This one's kind of challenging, so you have to kind of understand about sales terms and all that. So let's see if we can figure out what we should do first. He is selling them for $30, but there is cost involved. The profit is the amount in between. So let's find out what the profit is. Sale price minus cost, and this is all money. To find out what's left, and profit. And so for each math manipulative packet, he's going to have $12 profit after he pays his bills. So if he wants to make at least $450 and he makes $12 profit on each one, then we should probably split that up to see how many he should make. So let's take our $12 in profit and take your $450. And this is also money. I'm going to leave the dollar sign out for now. And we're going to divide this to see how many we should make. So 12, 24, 36. And subtract. The difference between 36 and 45 is 9. And then that's less than 12, so bring down. If I divide 90 by 12, then I could probably get about 7. 7 times 2, 14. 7 times 1 is 7 plus 1 is 8. The difference between 84 and 90 is 6. Now, if I was to go on and annex a decimal and a 0 and bring this down and divide 60/10 by 12, I know that the exact answer is 5, because I know my multiples. 5 times 2, 10, carry the 1. 5 times 1 is 5 plus 1 is 6. Hello, Bob. Okay, so what does that mean? Well, it means that I have to make 37 and a half math manipulatives, because this is money and this is money. And we're trying to find out how many to make. So the problem here is that he's not going to make a half packet of math manipulatives if he still wants this profit. So what you can do is you can kind of look at this. Think about it this way. If you were to do the check and you did 37.5 times 12, you should get 450, and that's what he wants to make for his the money amount that he wants to make at the minimum, okay? But that's not completing the manipulatives. So you can't just say, oh, well, you people get half a manipulative. Yeah, you can't do all your math because you get a half set. So this is another question where they're saying, what do you do with your 0.5 that is not a whole one? So if you were to solve this, 2 times 5 is 10, 2 times 7, 14, 15, 6 and 1 is 7. This is your 0, and then 5 and 7 and 3, 0 and 10 and 14, 15. Okay, and then we have one place, and you go, okay, but he's making 450. And I'm saying, yes, but he's not finishing the math manipulatives. So what you want to do is you want to bump it up to the next hole. He must make 38 manipulatives in order to make the 450, because if you had 37, it won't make 450. So you have to bump it all the way up to 38, and then you would do, you would get more than what is needed, like 38 times $12 each, 16, 6 and 7, 8 and 3. 15 and 4. So 456 would be the amount of money that he would make when he makes 38 sets of manipulatives. So this is like the whole big picture. Not enough, okay? Even though you get the exact amount, he's got to make the full set, because you don't want to give somebody a half set, so you have to bump it up to the next hole. Woo! I'm telling you, these are a doozy. I hope this is helpful. Click subscribe and come back, and we'll see you on the next one. Goodbye for now.